Hi, myself Polished. You are welcome to my channel of Smart Polished. Today here I'm going to discuss about the machine learning Harvard University course of thoughts by Andrew Ng. It's 7 week assignment and exercise 6 assignment. How to solve it and how to submit the solutions. So let's go start it. Before that, I will recommend it you to watch all the video very carefully and take a self note for that. After that, they will give the assignment with that PDF file. So please read this PDF files very carefully how to solve the problem. Now you will get the code here. In this code, it is the main file ex6. It is the main file. No, you no need to change anything in the main file. Just you will change the functions as they told in the PDF file or formats. And also some of the things I modified here to better understand. So let's get started. So here the loading and visualizations of the data. First, the recommendation of the problem is first visualize the data. So for visualizations the data we are importing the ex6.data.mat file and we are plotting the data of xy. How the plot data is working, let's see. Before that, I mentioned in here already that plot data function is already completed, so no need to change anything in the plot data function. Till now, let's go and see how the plot data functions is they written over. Plot data is here, so the plot data function is written it over here. Okay, no need to change anything, no need modifications. So for simplicity, I am cutting the page of plot data function. Now go to the main function again and come to that. I am printing the just one message that program closed and go further, then press enter. Now training linear support vector machines. In this exercise you should have to import the mat x6 data.1.mat from file. After that, what happened, we are trying to change the values of the distance and boundary values of the c every time and want to see what's the happening. So first initializations they told to change the values of the c later. What they so told in the discussion AC plus B. Okay, so C is the value of the constant. So their first initialize the values that you see. In later, you will change the values in various to try in your better understand to what happened inside of it. You can try the values of C is equal to 1000 as the recommended. Now they're predicting the model. This model will taken given sorry. The model is taking this parameter x, y, c and linear kernels and other of these values, and they using the function train SVM train. They predicting a model where the model will give the x, y, c and linear kernel values, and one power of minus 20 values they will give. So let's see the train SVM. So what's they're doing. Before that, I also written over here that the linear kernel function already completed, so no need to change anything in the linear kernel. Just what happened, linear kernel is calculate the similarities between the two input values. Okay, so let's go to first the is SVM trained. In the SVM trained, see this one is here. So this function is written over here and this function is complete. No need to change anything in this function. Just for your understand, for your better uses or understands, you can read the functions at least one time. After that, in this train SVM they are using the kernel functions. So let's go to the kernel functions and see how it's doing. Kernel functions, linear kernel. So linear kernel is here. This function is already defined. You need to no need to change anything in the linear kernel. Just it is calculating the similarities between two inputs vector and vector one x1 and another vector is x2. You can do imaginations with the x1 x2 values with the u and v values as this talk in the video. So no further decisions, I need this function, so I am call these functions. Now I'm going to the main function again, and after that we are plotting a visualized boundary linear is plotted a linear boundary limit in between two cluster or in between two data sets, which is in the most suitable distance from both data sets. I mean, from both ways the margin distance will be the same. Like this way it will plot a boundary limit. So how it is works, let's see. Before that, I already mentioned here the function visualize linear boundary is already completed, so no need to change anything inside the function. This function plotted is I already told. So let's go to the visualize linear boundary. So visualize linear boundary is last of the code here. Okay, see, it is the function of visualize linear boundary to visualize and to make a plotted line in between the scattered data, and in the middle of the line, in the middle to plotted data, that it will classify the data into more accurately. So no need to further of this functions already, so I'm cut it. So again I'm going to the main function. In the main function program is pause. After that we will implement the Gaussian kernel. When we will implement the Gaussian kernel, so we are taking to the values of vector x1 and the vector another one is x2 vector, and the sigma values are taken as 2. Now sim is the similarities calculating. Sim is the similarity calculating the Gaussian kernel. Let's see the Gaussian kernel how it is working. I already told here the finding the similarity of the Gaussian kernel. So you should have to modify this Gaussian kernel. Let's go to the Gaussian kernel. Gaussian function kernel function is there. So it takes in the x values and x2 values, and it will return the similarities. First similarity is initialized with 0. Now the similarity is given by the expression already in theoretical expression exp exponential of minus sum x1 minus x2 square divided by 2 sigma square. You can remember, you can get this equation number of times during the video of support vector machines of week 7. So this code is completed where here you should have to write only this code. Okay, fine, no need of this code again. So I'm cut it. So after that I'm going further. So here I'm showing the x1 values is this one, x2 and sigma values is this, and for using this value now I'm getting the sigma's values here, this one, and the similarities value is here, this one. Again we are going for the another data set. This is for the data set 2 and we want to visualize the data set. Here first we are importing the data sets. After that we are plotting the data set. After the program is to post. Now we want to train the data sets of two support vector machine with RVF kernel of for data set 2. So dataset 2 is imported again to be using for training support vector machine with RVF. We are taking the constants, the values c1 is equal to 1 and sigma value is 0.1. Now wrote over here we said the tolerance and maximum pressures were here that will run the faster. However, in practice we will want to run the training to convergence. So how it will work, it will predicted a model or return a model, and the return model will calculated by using the function of SVM train. SVM train I already discussed. In the SVM train it will return the x values, y values, c values, and with the argument uses of x1 and x2 it will gives in the Gaussian kernel of x1, x2 and sigma's value. So Gaussian kernel already I discussed before. Now we are making the visualization boundary for the dataset 2 by using this function. I already told the visualized boundary linear, but it is the visualized boundary. You should have to calculate this function properly. So visualized boundary is here. In the visualized boundary, this code is completed, so you don't need to change anything from this code here. For better understand, you can read the code and line by line at least one time. So no need of this function, so I'm cut it out. For that, the visualizations of the dataset 3. In the dataset 3, we are importing the dataset first, we are plotting the datasets in the next. After that, we will train the dataset with the RBF kernel for the dataset as same before. So just the dataset is changed. For that dataset, we are importing the dataset first. After that, we are calculating the C and sigma value by using the dataset 3 params functions. Dataset 3 params functions will used x, y, and x value, y value, and it will return the C and sigma value. How it will work? Let's see. Data 3 params. Data 3 params, this function is partly filled. You should have to write the code little bit to return the proper value of C and sigma. First initialization, the C values as 1 and sigma values is 0.3. So how it is work? So to get the proper C and sigma values, we using the for C text in a range of 0.01 to 30 and for sigma text 0.01 to 30, and we are making the loop of in these two values, like error row is equal to error row plus 1, like this way we are implementing. You should have to write this code, okay, from your side. You can see here, to better understand, you can write this code from your side. Business page is needed. Okay. So I'm cutting out this code. Now train the supervisor machines models. Train SVM. Train SVMs is given the model by using input output C and with the argument of x1 x2 and using the Gaussian kernel x1 x2 and sigma, and it will plot a visualized boundary for x and y in the model by using the model for the dataset of 3. Up to here, all the training on the process is complete. Your first part of the assignment is complete here now, so you can submit it here. um, it is the first part, and the second part of the assignment is also there. So if you submit the assignment, okay, if you submit the assignment, it will there is a 4 tasks. In between the 4 tasks, 2 tasks will be graded properly. So instead of submission of like this one by one, I'm submitting at a times one. So I will go for the second solutions and second assignment problems of this exercise. It is given an exe.spam, means spam mail classification problem. In the spam mail classification problem, you will deal with the function and email processings will here. Email file content will get the file, what is the file inside content. Before that, should have to read the file, whatever the file is ahead. For that purpose, we are importing the email sample one.txt file, which is taken care by how to text this content by the read file function. So let's go there, a read file function, and how it is works. Let's see. This function is already taken, sorry, already is completed, so no need of to choose to change anything in this function. Another one is word indices. Word indices, I mean, we are calculating the index of the words for the file contents, for the file content by using the function of process image. So let's see how process analysis works, and it will return the indices from the email bodies. Okay, so processed emails, we are going there, and processed emails is, yeah, partly complete. So you should have to read the code for that to complete the functions. First word indices is taking the email contents. After that, what happened exactly, it is taking the vocabulary list of get vocab list. From vocabulary to get vocab list, it takes the vocabulary list. So get vocab list is here. So it is large, it is a file, it is already defined. So in this file also, you know, no need to change anything or modify anything, or no need to write anything here. So in get vocabularies we are getting, after that where we will properly return the values of word indices. So what happened in this scenario, I am talking about very least short manner, that you will first make all the email contents alphabetic in lowercase. After that all the values of the email content, unwanted character, unwanted sample, digit number, email header, http, those things you should have to remove. Okay, http header are the things you should have to remove this thing. It is doing like that. After that, okay, we are doing the tokenization. So, okay, actually let me tell you one more thing. So when we go for data scientist job, or when we are dealing with the data, we are dealing with the same. We need to first take the format and the text format, then you data cleaning part it is actually calling told data cleaning we are doing here. After that data tokenization is we are doing here. So this part is tokenization. They already defined the tokenization, how to define the tokenization, but you will complete the coding here. That if any indices, okay, if any spam indices already defined, its catch matched, okay, is found by using the string and the vocab list is exact, we will getting the, I mean it is matched the string. And if it is not empty the indices, then what indices they will return the what indices value and the indices which indices it is found. Just you should have to write this code only, this much code enough, and this part already defined by them. So this function is also already over. I'm just going to the main again. So we are printing, and then what indices will be like that, and what indices will be this one, and the program is paused for further proceed. We are going for feature extractions from an email. For feature extractions, we are reading the file in the same way. After that, whatever the file is contained, we are doing the word indices by using the processed email. After that, we are calculating the features of the word indices file, where email features will give the word indices. Okay, so let's take a look at the email features. Email feature is here. In the email features you should have to write a small code for that. See, this function is already given, and n is the number of the feature is already given. You should have to properly return the values of x. Okay, so you should have to write the code only this one, that I is equal to 1 to size of the word indices. In this for loop, if the word indices is of I is equal to found, then it will initialize as 0, like this one. If the any this position the indices is matched, so it will be initialized as 0, this much only. So you should have to write only this much code, sorry, this much code. Okay, fine, this function is already over. Now you are printing the length of the feature, and sum of the feature is greater than or equal 0 we are printing here, and whatever the feature is greater than 0 we are printing only this feature. I mean the spam indices, whatever we found is spam indices we are showing here. After that, the next thing is training linear support vector nursing for spam classification. In this range, we are loading the data spam train.max. After that, we are dealing with that. Okay, we are taking the c value constant 0.1, and model will predict a model will give the one model of support using the function of train, SVM train, where it is using the argument of the features like argument, you can say x, y, c, and linear kernel. Okay, um, another conditional takes, and it will return the model. And we are printing the training accuracy by mean double p is equal to y of 100. And okay, test spam classification. So we already spammed we are spam classification, but now we want to test it. Spam classification, you can do it for your own dataset as they told. So for that reason, so they are taking spam dataset math this dataset, and from that dataset they are calculating the p values. P is the predictions value of SVM predict, where SVM predict using two argument model and xtext. So what is SVM predict? Let's see here. SVM predict, it is the SVM predict function. This function is complete function, so you no need to change anything in this function. To better understand, you can read one times. Just sit. Now top top predictions for spam. It is for your exercise purpose. You can try with your own data with your own mail. So it will return the weight and id, sorry, indexes values, and it will return to the weight and indices values in descending manner. Descending manner means whatever the indices is found in the frequently, whatever the word is found in the spam mail frequently, this will come first. And get vocab list, already told, get vocab list and getting the vocabulary list. And this things for as equal to 1 to 15, only the first 15 indices they are taken, and for that they're printing that in their vocabulary list that this indices of weight, this is found frequently, and it is your own data set regarding the sample data set they are taking, and file content is the same. I already discussed these things, but it is trying to for your purpose, so you can write this thing from your side. So this function is left, so this function is nothing. I think it is the uses of anywhere, but I never got the point before. But okay, no need of changing this function. So your main file is that one x6.m, and followed by you should have to do the second text of this one x6.spam. So let me try to submit the solutions, to submit the problems, to get the solutions, and we'll evaluate that. So okay, x6, it is the loading data, it is the first data sets. Okay, first data set and decision boundary is found by the function is a decision boundary. Now Gaussian kernel, sorry, let's see here, Gaussian kernel x values, x2 values and sigma values is there, and for that value they are also finding the, that should be this, and it is the second data set, and the visualization of second data set. And now the second data set is now training, and it will come to the decisions with it decision boundary values of green plotted line. Now press enter for furthers. Okay, it is the third data sets, it's like that. Now the for third data sets, now it is going for training, and it will predict the decision boundary again to classify the data set of cross and yellow colors of round. Okay, it's found. So and program is already completed, so all the assignment of first is already completed, and let's go for second assignment. Ex is the spam. Okay, this one. So I'm running it from my environment. Okay, so in that email, okay, in that email the word indices found is like that. Now proceed it further. In proceeding with like that, and length of the feature vector 1899, number of non-zero entities is 45. This is founded, and it is now for spam classification. It's now the training with that text data, and it will come to the decision that it is spam or not. And what about the which of the word is come frequently. Before that, in the meanwhile, I will request you please subscribe my channel, like my videos and share my videos, because it gives me the motivation and spirit to me to make more educational video like this. Or if you demand anything educational purpose, any videos like this, you can put a comment in the comment box. Okay, so actually it gives me the inspirations to do better to upload the educational video like this. So I hope you will do for the little things for me. So okay, now it will got the training accuracy of 99.82 percentile and evaluate the training linear support vector machine on text dataset, and text accuracy is 98.70 percentile. Now this is the word in descending manner. This word is coming in frequently in a spam mail. Okay, with the indices of like this and word is like this. Go further proceed. For that email, the spam classification is showing one. I mean that is the completely spam emails. Okay,